Hello, and welcome to a Microsoft Excel how-to video. I've had a lot of requests for this. So this video is going to be a sort of general how to graph things in Excel. And the context that we are going to use for this is an exercise, an actual lab activity that I give to my students, which is to create X bar and R charts. These are sort of standard SPC charts, statistical process control charts, that we use to sort of determine if our manufacturing process is, basically producing good parts. There's a lot more to it than that, but in a nutshell, that's what SPC is. So X bar and R are two basic charts we use to do that, and they're also a good example that sort of runs us through the ins and outs of how to graph things in Excel. So what I have here, really, the nuts and bolts of this thing that I have open. This is a piece of the data set that I give my students for that particular exercise. There's a few more columns with some more. These represent measurement data taken at an hour apart. And there's, in the full data set, 3 attributes. So these 3 samples, an operator would have pulled 3 parts and measured whatever this attribute is, a dimension on that part. Then in the full data set, there's 3 more for attribute 2 and 3 samples for attribute 3. So they measured 3 different dimensions. They pulled 3 parts every hour and measured those things. But for this sort of how-to guide, and also we go basically 24 hours here from 7 a.m. to 6 a.m. the next morning. The full data set, I believe, includes 3 days. So there's a lot bigger data out there for the full exercise. But again, in this simple how-to video, we can cover sort of everything we need to do to get these charts going. And then it can be expanded on if your data set's bigger. So it's good to start, sort of small. So the first sort of how-to thing is a thing that's sort of hard to teach without a bit of experience. And that is, there's actually a massive problem for us in the way that this data is presented. So what I'm going to do to sort of demonstrate what the problem is before I actually graph my X bar and R charts, I'm going to go ahead and graph the data for sample 1. So I'm going to go ahead and create a graph, and I'm going to sort of walk through and show you what the problem is with the way that this data is presented and how we can go about fixing that. So first of all, to plot this, I am going to just simply, click in my time. So it's got the green box around it. It's highlighted. I'm going to click in there somewhere and I'm going to drag so that I'm now highlighting a lot of stuff. And I'm going to plot this by shift. So generally speaking, in manufacturing, a shift is from 7 to 3. That would be 1500. So the measurement at 3 o'clock, we could consider that, say, the last measurement that first shift took. So I'm going to highlight that, and I'm going to come up to my Excel toolbar here to the Insert tab. And then I'm going to click on Insert over in the middle where it says Charts. Sort of the last icon of these little groups are scatter plots. And I have to be honest, most of the time, unless there's a very specific reason that I need something else, I'm going to be creating a scatter plot when I open Excel. There's a lot more flexibility that Excel gives you as far as how to set up your graph if you use a scatter plot versus any of the other types. So it's primarily due to the flexibility that I recommend sticking with the scatter plot. So I'm going to go ahead and click this drop down. I want to insert for now a scatter plot with no lines, just a straight up scatter plot right here, the very first option. I'm going to click that, and I get a graph of the data that I selected, right? Times are along the x-axis. They don't make a whole lot of sense right now. They're not broken up by hour. That's because when we first insert a graph in Excel, it tries to automatically determine how we want, sort of these, they call these major divisions, how we want those spaced. It sort of sets its own minimum and maximum. You notice the minimum is at 0. On the y-axis, it's not at 0 because our measurement is so much bigger than 0. So it automatically tries to define limits for us. Sometimes it does a good job. Other times it doesn't. And we'll walk through how to change that and get it looking the way that we want. So this represents first shift. How do I represent the rest of the shifts in a way that I can actually see what shift is what? So to do that, I can actually add second shift, which would typically be you know, from 3 to 11. So I'm going to grab the 1400, which would be the first one I didn't graph yet. That would be the 4 o'clock would be second shift's first measurement. But I'm going to right click on my graph. I'm going to come to select data. And first of all, the first thing I'm going to do is I'm going to edit this sample one. Because I grabbed this title here, it thinks that's what I want to call that, but that's not really what it is. I'm going to edit this. And in here, I'm going to delete this sort of formula that Excel put in there. And I'm going to call this first shift. That way, when I open this window in the future, I know exactly what data set I'm looking at. I'm going to be editing data sets later. I know what I'm looking at. I know which one I need to click on to edit. So it's a good habit to actually name your data sets something meaningful in this little data source window. So to get second shift, I'm going to add a data set. I'm going to name it second. I'm going to click in series X values. So the X values along that X axis, again, I'm going to click in the 4 o'clock and we're going to go to 11. That would be second shift. In Y values, it's important. I'm going to first select everything that's in there. By default, it's usually this equal bracket 1 bracket. I'm going to select all that. I'm going to get rid of it. Excel tends to freak out if we just try to click and overwrite that. So it's best practice to get rid of it for now. And I'm going to click in the first data at 4 o'clock and drag down again to 11 o'clock. And you'll notice in the background there, I now have orange dots representing second shift. So I hit OK. I now have a second data set. And for third shift, I'm going to do the same thing. I'm going to add. I'm going to skip the name. Well, name I can enter third. For X values, we stopped at 11 o'clock, and midnight would be the first value that third shift reads. So I'm going to go 0 to 6 for X. Again, I'm going to blow away everything. I'm just going to delete everything in that Y value. And again, I'm going to select midnight to 6 o'clock. Now, I'm going to hit OK and accept that. We have a problem because the new data set for third shift is represented here from 0 to 6. Because as far as Excel is concerned, this 0 is smaller than this 7. Even though if we were to look at this data as humans intuitively, we know that this is the next day, right? We've rounded over midnight. Excel, though, only knows what we've programmed it to know. And the way we've listed this, these are smaller because we haven't given it a day. We haven't told Excel that this is the next day at midnight or the next day at 1 o'clock. So that's the problem with this data set. We need to make this a full date with a time so that Excel can figure out that these things are actually in order. So I'm going to go ahead and I'm going to delete this graph because we're going to recreate it. But the first thing that I need to do really is I'm going to leave this column here, right? I'm going to leave this column here just for reference so we know where we came from. I'm going to right click on column B. I'm going to insert. So I now have a blank column here. Okay. I'm going to enter again time. That's going to be the column title. And this time I'm going to enter, now this is completely made up because I don't know what the actual dates were for these. I'm just going to enter today's date, which happens to be 4/9/2025, space, and the 7 o'clock. Now, it's important to note, too, that when entering times, Excel does hours, minutes, and seconds, space, and an AM or PM. If I hit enter now, notice it chopped off the seconds and the AM. That's actually a good thing. When Excel reformats stuff for us, it's a good indication of what Excel thinks we want. So when it does that, I can immediately see that Excel thinks I want a date and a time, which is exactly what I want. So it's a good indication that that it's doing sort of the automatic thing right. Now, I'm going to do the same thing in this cell, but I'm going to enter 8 o'clock. So 4/9/2025, space 8:00:00 AM. Okay, it chopped it again, so that's good. Now I could continue typing, add all of these in manually for these blanks, 9 o'clock, 10 o'clock, so on. But Excel has a really cool feature for doing copy and pasting of a lot of data and formulas. What I'm going to do is I'm going to click in the first cell that I entered here, the 7 a.m. I'm going to click and drag so that I've got both of these highlighted. And I'm going to come down here to the little box in the lower right corner of that selection. And my cursor will change from the sort of big plus sign to a narrow plus sign. When it does that, I'm going to click and hold and drag that box all the way down. And as I'm dragging, you can see the little tooltip next to my mouse where it says 4/9/2025 at 20, 121. So as I do that, because I've got two cells selected, make it a little bigger so we can fit more time in there. Because we had two cells selected, Excel assumes that I want to add an hour every time. It's just an assumption Excel makes, and it's something that can greatly speed up sort of copy and pasting or entering formulas. I don't have to manually type. I do have to remember that I have to have data in two cells at least so that Excel knows how much I want to add. Because I could also go in 15-minute intervals. If I did change this to 7:15 a.m., just for example, I can click this now and drag down, and it's going to add 7:30, 7:45, 8 o'clock. So it'll go in 15 minutes. So I need at least two cells so that Excel knows what the interval is. The cool part is this also works in reverse. So I don't have to retype the ones that I just changed. I can do the same thing, select two cells. These are correct. The 12 and 1 o'clock are correct. I can click that little box again, and this time I can drag up, and it's going to count down. So if I drag up all the way to my 7, I get my hours back. So this is sort of the format that I want, because when I go to recreate that graph, now Excel will understand that we sort of flipped over midnight and we're on the next day, and it'll put the third shift data set on the right side of the graph. So I'm going to go ahead and do the exact same process I did before, except instead of the time, this first time column, the original. In fact, I can delete that now. I'm just going to right click on A and delete that whole column. I'm going to go ahead and select time, and I'm going to go up again through 3 o'clock, because 3 should be the last part that first shift actually measured. I'm going to insert, again, go to scatter plot, sort of the last option. I'm going to right click, select my data. I'm going to edit because I want a name in there. I'm going to call this first. I'm going to add a data set. This will be second. The X values would be 4 o'clock through 11 o'clock. Blow away, delete everything in the Y values. And again, select 4 through 11 for the Y values. The orange dots popped in as the next sequence, which is good. Okay, I'm going to add third. And for X values, that's going to be midnight to 6. Delete everything in Y and midnight to 6 for the data. And my gray dots now, once I hit OK and clear out, are on the end where they belong. So using that trick and sort of adding a date, even though I made up the fact that it's today and tomorrow, you know, for the purposes of this exercise, it works. But it's a good lesson in that if you are collecting data, period, that will be entered into Excel, it's a good practice to get into listing both the date and the time. If it was just a date, for instance, if we were just taking one measurement today, one measurement tomorrow, one measurement the next day, we would be fine to not list a time at all, because those days will go in order. But if it includes a time, it's a good habit to, in the same cell, give Excel a date so that when it comes time to plot, we can get things in the proper order. So that's sort of the basics of creating a scatter plot in Excel, and especially with a date and a time. So I am, again, going to delete this, because the real purpose of this particular lab is to create X bar and R charts. What I've graphed here would be called an individuals chart, which is a different statistical tool. And it's basically a graph of the actual measurement the operator took. The X bar and R charts are not graphs of the actual measurements. X bar is a mathematical term for the average. So what we're actually going to be graphing in the X bar chart is we're going to be graphing the average of the 3 parts that were measured at 7. We're going to be graphing the average of the 3 parts that were measured at 8. We're graphing the averages of these parts. The R chart, R stands for range. So we're going to be graphing the range of these measurements for the 3 samples at each interval. And the range is simply the biggest measurement, the maximum, minus the smallest measurement, the minimum. So those are the target graphs. So I'm going to go ahead and delete this because this isn't what we want anyway. What I want to graph first is going to be my X bar chart. So I'm going to add a header here in column E, and I'm going to call it X bar because that's what I'm going to graph in my first chart. Now, X bar, again, mathematically is a statistical term. It's just the average of these 3 samples. So I could, in here, enter equals and parentheses, and I always recommend overusing parentheses in your Excel math. Excel is okay with the order of operations, but sometimes, especially as formulas get more involved, it loses its mind a little bit and things get out of whack. So overuse your parentheses. Make sure you've got things sort of grouped the way you want them when you enter the formula. So parenthesis, I'm going to click in B2 to grab that cell plus C2 plus D2. Parentheses, and then divide by 3 to get an average. And there's the average of my measurements. Now, I can use a similar copy and paste technique as I did before with the dates. I can click here, and because this is now a formula, I can grab this box in the corner and drag down, and it won't give me a little preview, but I can drag down. And if I look, so the one that I entered was B2, C2, D2. As I drag down, Excel automatically updates those references because it's in a new row. So since I dragged it down to row 3, it's going to update these to take the next, B3, C3, and D3. That's an easy way to, again, fill a full data set. So if I click this again, drag it all the way down, I get averages all the way down. That is if I want to only ever take an average of these 3 parts. This works just fine. Excel, though, also has a built-in average function, so I don't have to do a formula that complicated, the B2 plus C2 plus D2. All I need, I'm going to go ahead and delete all of that. In this first cell, equals, and I'm just going to start to type average, and a little tooltip pops up. I can press Tab because that's the one I want, and it selects it. And then I can click and select all 3 of these, and the little colon here in the middle means it's a range of cells. So it's not individual cells, but it's going to look at all the cells in that range from B2 to D2 and take the average. And if I hit enter, it's the same average as what I got when I calculated. So 2 ways to get an average. I probably recommend using the built-in average function. And I'm going to go ahead and do the same, click and drag down. And now I have all of my X bars populated. So again, these are the things that I want to plot. So I'm going to go ahead and select from 7 to 3 and 7 to 3 and insert a scatter plot. And then I'm going to select from 4 to, I'm sorry, we have to first select the data, edit and rename. This will be our first shift. Add. Now I can enter second shift and select my data. Second shift, X values from 4 to 11. Delete everything in Y and select from 4 to 11. Okay. Add. Third shift, X values from midnight to 6. Y values from midnight to 6. Okay. Okay. And now there's my data plotted. Make this a little bigger just so that we can see it. So this is our X bar chart. Okay. There's still some formatting to do. There are some rules we have to follow. If you've noticed over here, sort of irrelevant to the data, I've copy and pasted some formulas and a table just for reference, so I don't have to click back and forth between windows as I'm sort of walking through this. But we basically, to make this chart useful, we've plotted the averages of those three measurements. We now need to plot a center line and the control limits, sort of the upper and lower bounds of these measurements. So first, I'm going to sort of do a little bit of formatting here. For instance, notice that Excel, when we create this graph, sort of spaces these, vertical grid lines out in sort of an automatic way. Like Excel really likes to try to automate it, thinks it's making our life easier, but in a lot of cases, this doesn't make a whole lot of sense, these divisions, right? It's even. I mean, it certainly broke them up evenly across here, but 9:36 a.m. and 9:36 a.m. and 2:24 p.m. don't make a whole lot of sense for divisions, especially when we're taking measurements an hour apart, right? So it would be helpful if we could, resize this to something that makes sense. And we can. So I'm going to click on this. I'm going to right click and format my axis. And I get a little pop up over here on the right side with all the details. And on this rightmost icon that sort of looks like a bar graph, that's my axis options. The bounds here will tell me the minimum and maximum value of the x-axis. And if you notice the numbers that are stored in there right now, those are not dates, at least dates as far as we are concerned. They are, however, the way that Excel stores dates. So Excel uses a thing called the 1900 date standard. Every date in Excel, like for instance, this 4/9/2025 at 7 a.m., is stored as a number. And that number represents the number of days since midnight on January 1st, 1900. Which is honestly, a weird measurement to try to wrap our heads around, and it causes all kinds of pain, especially when we need to plot dates in Excel. But it is what we have to work with, and there's not really a great way to get around it. So it's sort of what we're forced to do. And if I click in this axis again, you can see, so what this represents, the minimum bounds, and if we look over on our graph, 4/9/2025 at 4:48 a.m. is what they've labeled sort of zero here. It's not zero, but that's where the axis starts anyway. That translates to a number of 45,756.2. That means that date, 4/9/2025 at 4:48, is 45,756.2 days since January 1st, 1900. We would like to make this minimum, maximum, and the divisions here on this axis make sense. And it's kind of tough to do that when we have no idea. I mean, there's no real easy way in our heads to figure out what that distance should be, what these 45,000 values should be for what we want them to be. Cool part is that we can actually force Excel to sort of tell us what that should be. So how do we do that? First, I'm just going to move this down to open up some cells so that I can do some work. I'm going to grab this 7 o'clock here, this first data point. I'm going to copy it with Control C, and over here somewhere, I'm going to delete these in a minute because I don't actually need them. But for now, I do. Make this a little bigger so we can read it, paste it. I'm going to cut this back to 6 a.m. because I actually want my axis to start a little before my data starts. So I'm going to cut this back to 6 a.m. and hit enter. I'm going to do another paste. So copy and paste, and there's a reason for that coming up. But I'm also going to grab this last one because I want my graph to end at 4/10/2025 at 6 a.m. So I'm going to grab that and I'm going to paste that. So I've got an hour apart on these two, and I have the last point. So my axis will start here. I'll show you in a minute why I grabbed another hour. And then I want my axis to end here. What I can do to sort of figure out what the min and max should be, I said I could force Excel to tell me. Right now, if I select all of these and I right click and I format the cells, they are formatted as on the number type here, they're a custom number type, and they are formatted as month, day, year, hour, minute. That's the format Excel is throwing in there. If I switch them to a number, notice the sample is telling me what one of the cells is going to be. It is giving me the numerical value for that date. And again, 45,000 whatever represents days since 1900, January 1st, 1900. So it will tell me if I hit OK now, those shifted to numbers. So this is now telling me what numbers I need to put into my axis. So if I click here again, click on the axis, and I go back to my axis options on the right. So my minimum, I want that to be 45,756.25. My maximum, again, I want to end it at 45,757.25. Enter. And notice my axes shifted, and we will clean these up so we can actually read them in a minute. But my axes did shift to 4/9/2025 at 6 to 4/10/2025 at 6. So my bounds are correct. My divisions, however, and actually let's arrange these so that we can read them now. So if I click on axis options and I click on labels, I take that back. We need axis options here under alignment. Text to direction is horizontal, but it lets us enter an angle. So for dates, because dates and times are especially long, I recommend sort of an angle, and I'm going to go 45 degrees. Okay. That's backwards to me. I don't like it that way. I'm just used to seeing graphs the other way. So I can just enter a negative 45. And notice it rotated all the text so that, now we can read it at least a little bit. So I'm going to hit enter there to accept it. So our min and our max are where we want them to be now. But the divisions are still automatically generated, and the divisions still don't make much sense, right? We don't have really divisions at even hour intervals. So we can force Excel to tell us that too. That is why I grabbed an hour apart here. I know that this is 7 a.m. I know that this is 6 a.m. on that day. So I am in this cell, I'm going to enter a formula equals the 7 a.m. number minus the 6 a.m. number. And the result will be what Excel considers to be an hour, right? And I'm going to format that and increase the number of decimal points. So if I bring this out long enough, and you notice the sample now, what this represents, again, Excel is counting, when it does a date, Excel is counting the number of days since January 1st, 1900. 1 hour is 1/24th of a day. So 1/24th, if we were to punch that into a calculator, would give us a decimal point that looks a lot like 0.041662, all of this, right? So I can shrink that down because the 0 should repeat after that point. This represents an hour as far as Excel is concerned. So that is 1 hour. I could get the same result if I do 1 equals 1 divided by 24. It is 1/24th, right? Same result. So that is what Excel considers to be 1 hour. So I'm going to come in again. I'm going to click on my axis, and where it says units, major, that's where these vertical grid lines are located. Those are the major units. I'm going to enter 0.041. How many sixes? Looks like 5, 2, 3, 4, 5 sixes and a 7. Enter. And notice now we're nice and happy with 1 hour spacings on our graph. So that's sort of, it takes a few extra steps to get Excel to play nice with dates and times, but that's sort of what's required. And especially in understanding that, it's how it measures as far as days since 1900, which is a weird thing to wrap our heads around, even still, this many years into using Excel and having messed with this, I don't know how many times. But if I click on this axis, notice I stopped short. That's because I rounded, right? So it's not 5 sixes and a 7. It's actually this whole number that's located in this cell. And unfortunately, I can't just reference that. I have to type the whole thing in. So let's restart and enter looks like 4 sixes. 1, 2, 3, 4 sixes. 0, 8, 7, 9, 8, 5, 5, 0, 4. Enter. And we get our 6 o'clock back because now we are exactly at an hour per division. Before we were off by just a little bit, and it was enough that at the end of our graphic cell sort of chopped off 6 o'clock. But we've got it back now. We're happy. We can move on with our lives. And because I haven't actually referenced these cells, I'm not using them in formulas. They were just there to help me do a little math. I'm just going to go ahead and delete everything in them. Right? Nothing changes. It didn't hurt anything. They were just there to be, their purpose in life was to be temporary. So this is the start of our X bar chart. Now, there are a few things that I need to add to it to make it a true X bar chart and to make it useful for us. And those things, I'm going to go ahead and delete a few columns to sort of move my pictures back, into view. And of course, when I did that, it shrunk my graph to match the columns that were deleted. So let's do this and let's slide this over. That sort of works for a minute. So the X bar chart typically, well, not even typically, always includes a center line, a lower control limit, that's LCL, and an upper control limit, UCL. And these formulas determine how we calculate those. So what we need is basically now to work through these formulas, we need these variables because we're going to add them as lines on our chart. So up first is the center line. That's sort of the simplest. The center line is simply X. We call that X bar bar. X bar bar is called the grand mean. It's just the average of averages. So column E here, the X bar column, all of these numbers are the averages for each set of 3 measurements. X bar bar is just the average of that whole column. So I'm going to go ahead and move my graph for now out of the way. And I'm going to label a cell X bar, and next to it, I'm going to hit equals, average, and I'm going to grab that the whole thing, X bar column. And close my parentheses, always close my parentheses. Again, Excel sometimes gets it right. It could automatically close the parentheses. I don't typically trust it, so I make sure to close them every time. And we now have the average of all of these X bars. That is going to be our center line. So I'm going to go ahead and throw that onto my axis. The easy way to do that, I'm going to right click on my graph. I'm going to select the data, and I'm going to add a data set just like before. I'm going to call this CL for center line. My X values, I'm going to equals. I'm going to select the first timestamp, comma, and I'm going to select the last timestamp. Y values, I'm going to delete everything in there again and press equals. And I'm going to select this X bar value, comma, this X bar value. Press OK. And when I hit OK on this, I've got at least one. It looks like this other one may have been cut off at the end, but that's okay. We'll deal with that in a minute. But I have a yellow dot now that represents the center line. We will deal with that in a minute to make it an actual line. But what I did there was I defined 2 points. And 2 points, because I know that the center line is a straight line and it's in the middle, all I need are 2 points to define any line. So I'm good there. I could leave that alone. I don't need to see the other marker. In fact, I probably don't want to see the other marker. And actually, what I probably want to do, now that I look at this, we got our 6 o'clock label back, but we're also missing a gray dot, which should appear at 6 o'clock. So I probably want to tweak my axis one more time and round this up just a little. And if I go and just round up to 7, does that give me enough? No. See, it accumulates. Now I jumped from hour divisions to 401, 501. So that doesn't work. What if I increase this to my maximum to give it another half hour or so? There we go. Now I get at least my my last dots there. Give it another half hour ish and round it up to 0.3 rather than 0.25. Again, Excel is tricky with dates, especially with the system that they use, that whole 1900 date system. So it's a thing that unfortunately we just sort of have to massage until we get something that looks correct. So we've got the center line. Now I've got both yellow dots on each end, right? If I select the dots, you can see it highlights both. That's my center line. Now, for the lower control limit, I've got a formula to follow. I need the first variable in that formula is x bar bar, which I've already calculated. And actually, I mislabeled that, x bar bar. I've already calculated x bar bar, right? I'm going to subtract. There's some variable called A2. A2 is actually, I mean, it's in the formula as a variable, but it's actually a constant. And it's a constant that's based on statistical analysis of a normal distribution. And there's a whole bunch of math behind that. We can actually calculate A2. Or what's more common nowadays is the fact that we've been doing this sort of analysis for 100 years at least. And there are pre-made reference charts. So that's the second picture this table that I've sort of pasted into my Excel here is a reference for where the constants come from. And I've got the A2 constant. And then when we get to the R chart, they've got constants D3 and D4. Those are also in this table. So I can just look up A2 in this table for the purposes of my formula. And I'm going to drag this down just to get it out of my way again. And when I look, A2, this chart, the sample size is the number of samples taken for a given data set, for a given timestamp in this case. So I took 3 samples for every timestamp. So my sample size for the purpose of control limits is 3. I've got 3 samples per group. So I'm going to use the row that says 3, and I find that A2 is 1.0233. So I'm going to do another cell, label it A2, and put it in here as 1.0233 because I'm going to need that later. Now to calculate my lower control limit, I'm going to label it X bar LCL. I'm adding the X bar because when I go to do the R chart, I'm going to have a different set of LCL and UCL. Actually, it helps if I label that UCL. I'm going to have a different LCL and UCL for the R chart. So by labeling them, I can keep them straight later. So now in these cells, I'm going to do the math again. I'm going to press equals. The first thing I need is the X bar bar. For the lower control limit, I'm going to subtract, and again, overuse parentheses. So I'm going to use a parentheses. Even though Excel is okay-ish at order of operations, I'm going to enclose in parentheses to make sure that it does the math that I want. Then I'm going to click the A2 cell to grab that number, times Shift 8. The star in Excel is times. I can't just assume a times. I have to put a star. So Shift 8 gives me a times. And then R bar. Crap, I haven't calculated R bar, right? I can do that now. So let's calculate R bar. To get R bar, first, I need R because R bar, again, bar over a variable in statistics just means average. So first, I need to calculate R. R is going to be another column, and R is just the range of measurements per sample group. So the range, again, is maximum minus minimum, and Excel has built-in maximum and minimum functions. So I don't have to look at these and, in my head, pick which one's the biggest and which one's the smallest. I can use the Excel function. So I'm going to equals max, and I'm going to drag and select all 3 of these so that they're lit up and close my parentheses, and I'm going to minus min all 3 of these. Close my parentheses, enter, and that is the range for that first set of 3 measurements. Now I can grab the box in the lower right corner and drag it all the way down, and I'm going to move my chart one more time to get it out of my way. And I can click this box and drag it all the way down, and I've got a range now for every sample group. R bar then, R bar is just the average equals average of that range column. So I'm going to average and grab all of those ranges, close my parentheses, that's my R bar. So now when I calculate the control limits, equals X bar bar minus parenthesis, select the A2 cell, times the R bar cell, close the parentheses, enter. There's my lower control limit for X. Now I don't need to retype all of that. I can't really drag. If I drag, remember from earlier, Excel changed this instead of H2, H3, and H6. It changed it because I dragged down. It changed it, each one of these by 1. I can't have that in this particular formula, but what I can do is I can select this cell, and in the formula bar up here, I can select all of this, Control C to copy it, escape to get out, and then here I can select the formula bar and paste it. And when you do it that way, Excel does not update your formulas, your cell references rather, by 1. Now the upper control limit rather than minus is a plus. So I'm going to delete that and put a plus sign instead, enter, and there's my upper control limit. So now all I need to do is get those added into the graph. So if I right click and select data again, select data, I want to add an upper control limit, X values equal, again, the lowest value over here, comma, the biggest value over here. Y values, delete everything, and I'm doing the upper, so I'm going to grab the upper, comma, upper. Press OK, and get rid of that so we can see I've got sort of a light blue dots here now at my upper control limit. I'm going to do, again, select data, add in my lower control limit, LCL. X values, again, equals smallest one, comma, biggest one. Y values, delete it, and I'm going to select the lower control limit, comma, the lower control limit. Okay, I've got sort of a green dots down here for my lower control. Okay. This graph now is complete as far as getting everything that we need onto it. From here on out, it is literally all formatting. There's no real formulaic shortcut to make this happen. I suppose if we do this enough, it would be possible to create an Excel chart style that we can apply. For instance, if we click up here on the toolbar under format, rather design, right? There's a whole bunch of chart styles, and just clicking these, you can see the chart changing as I hover over them. I haven't clicked any. You can create a custom style and sort of shortcut some of this formatting. If you do enough of this, that might be worth it. But it's really not a big deal to format this the way we want. So the first thing I'm going to do is I'm going to format our data, our actual data series, our X bar series. So I'm going to click one of the blue dots that represents that series. Notice they all light up, and it highlights the data in my Excel columns that that series comes from. So I've got that clicked, and as soon as I clicked it, on the right side, it changed to Format Data Series over in this window. This is where I'm going to make all of my changes to make this sort of look more professional, make it look a little better. So under Series Options, or rather under the sort of paint bucket, the fill-in line, first, I want to add a solid line. Right now, all of my dots are connected. So I've effectively used a scatter plot to create a line graph. And I did that, even though this is going to look a lot like a line graph, I did that because it gives us better control over those X values. We don't have that kind of control if we would have started with a line graph. So the rest of this is really, like I said, formatting mostly for appearance. So I'm going to change the color of the line. I like everything in my graphs to be black if I can help it. So I'm going to set it to black. I'm going to shrink the line to 0.75. Under marker, the border color, I'm going to change to black. And then I'm going to expand fill and also change that to black. So if I sort of click off here, I now have black dots with a black line connecting. And I'm going to make these other series. So the orange one is second shift. I'm going to go back to my paint bucket, and I'm going to add a solid line, and it comes in as black because that's the last one I did. Excel assumes that's what I want. I'm going to drop it to 0.75 again. I'm going to click on my marker and again change the fill to black and the marker to black. And if I click off, you can see I now have a black data series. And this is why I entered them as separate data series. Because now, as we look at this graph, there's a break in this line, and that break represents a shift change. If I had entered, I could have created a graph where I just selected all of this data and dumped it in as one data series. But if I had done that, there's no way to get this break. So I don't know then, just by looking at this graph, I have no idea where the shift change took place. By breaking the line between shifts, I can look at this graph and just in a visual instant know where that sort of break happens. That's why it's important to use different data series to sort of break up the data. And in this case, we also have the option to change markers. So, I mean, these have both round markers. Some people would prefer that each shift, because it's broken apart, like for instance, if I click second shift, I can come back over here to my paint bucket and now click on marker and marker options. And I have the option under built-in to change the shape. So I could make it like square, for instance. Some people prefer that. In this case, because there is a clear break between first and second shift, right? The line's not connected. I don't particularly think that that is necessary. Leaving them as round because there is a break is a clear enough distinction between these data sets. So I like to leave it that way, you know, in these cases. So I'm also going to click third shift and do the same sort of format. Click the paint bucket, line, solid line, drop it to 0.75. It's already black. And then the marker, I'm also going to turn black on the border and on the fill. So if I click off, now all three of those are connected. We are missing a data point. This data point at looks like 11 o'clock. So I missed it under somebody's data set. So looks like I missed it under second shift. If I click this data, it's showing me 2300 is included. That's 11 o'clock included in second shift, but I didn't drag down far enough. I can always edit that by right clicking and sorry, I need to right click in the chart, go back to my selected data. Second shift, I can edit, and I just need to make one change here. So here, rather than stopping at 17, notice that this stops at row 18. This stops at 17. I can just change that to 18 that fast, hit OK, and I've got my last data point. So also a good visual check between the two that showed me that I was missing data. So for our control limits in our center line, a lot of the same, except in this case, I'm going to get rid of the markers entirely because those markers don't really exist. The only reason they are there is one, because this is a scatter plot and we told it to put points there. But I don't need them. What I need is I need the line between them. So I'm going to go over here to marker options and I'm going to select none. And if I click off, I don't want to click off, because if I click off right now, there are no markers there and it'll be hard to find to figure out where to click again to edit this data set. But I'm going to click back on line. I want to make it solid. This is sort of counterintuitive what I'm about to do. I'm going to shrink it again, 0.75, and I'm going to make it dashed. Now, I just told it to make a solid line, but then I dashed it. And that's just sort of the way Excel works, is a solid line is basically any line between the data points. And then you control whether it's dotted or not, you know, with this little dash type drop down. So there's my upper control limit. I'm going to do the same thing for the center line, marker, options, none, line, solid, drop the thickness down, and dash it. Oops, wrong dash. Oh no, I grabbed the right dash. And then the same thing for the lower control limit. Solid line, drop the thickness, marker, options, none. And I forgot about the line, dash the line. click off, and this is what my chart looks like. And this, in a lot of cases, is good enough. This would be, sort of considered a complete control chart. I like a little more, call it publishable quality to my charts. If we look in academic literature, sort of research journals and things, this is not the way that graphs are usually presented. One big thing that I don't like about Excel's defaults is the grid lines. Grid lines are, generally speaking, unnecessary in graphs. It's usually assumed that we can sort of look at the graph without the grid lines and know where things line up. So I like to get rid of the grid lines, and that's as easy as deleting them. So I'm just going to click on a grid line, not between. If I click between, sort of the whole chart lines up. But if I click on a grid line, I get these little blue dots that mean the grid lines themselves are selected, and I can just press delete. That got rid of the vertical ones. I can do the same thing on the horizontal ones. Just select them so I get the blue dots and delete. Okay. We're close, but there's a few more tweaks, and this part is really, again, just getting picky and getting into that mindset that I want this to be sort of a consistent look and presentable. So what's left is, by default, these axes are not quite black. And that's one thing I want to do, is I want to select this axis. Over in the format, I'm going to select the paint bucket. Under line, it's already a line, right? It's just gray. So I'm going to change that gray to black. Right? And if I click off, it's now dark. Notice it's darker than the y-axis. I am also now under axis options, under tick marks. I'm going to select major type, and I'm going to put them outside. So now each one of these lines lines up with these sort of time labels. And that helps us, again, visually look at the graph and know where things line up. So now I'm going to set my y-axis up the same way. And, tick marks are already selected, so I'll change that first, outside tick marks. Come over to my paint bucket and just change this color for the line to black. And it'll change the tick marks and the line all at once. So there are a few things that are missing to make this graph sort of complete now. One, we always, no matter what, need labels on our axis so that we know what we are looking at. So that is easy. I'm going to select the chart. I don't need to select an axis. I can just select the whole chart. And up on the chart design tab at the top, I want to add a chart element. Go to axis titles, primary horizontal, that's the x-axis. And it's lit up in blue here, right? Blue circles. I can just start typing. I don't have to do anything fancy. I don't have to click in. I can just start typing. This is going to be date and time, and hit enter. And now I have an axis label. I'm going to do the same thing. I'm going to add a chart element, axis title, primary vertical. That's the y-axis. Again, it's already selected, so I'm going to label it average measurement. And it is important with your data, whether it's X or Y. In this case, date and time is pretty self-explanatory. If that was in hours, I would want to make sure that I labeled it as hours. Here, I want to put a unit here. Now, I don't actually know what these measurements were in when they were taken. They could be millimeters for all I know. But for the sake of completeness and demonstration, I'm going to make sure to put units in there. I'm just going to assume they were inches, right? So the average measurement in inches, that's what X bar is. Then sort of the last thing that the chart is missing is a title. We always need a chart title. And the reason we need these things is because the rule of thumb is that any figure, and a chart is a figure, it's a picture, should do what they call stand alone. I should be able to take this chart out of this spreadsheet, hand somebody a printout of just this chart, and they should be able to know what we're looking at. And right now, without a title, without axis measurements, that's just not possible. We don't know what this is. So we need a title, we need axis labels so that this chart sort of reads as a complete story. So again, I inserted the title. It's lit up already. I can just start typing. I'm going to call this X bar chart. And if I actually knew what these measurements were, I'd be more descriptive than this. But for now, I know it's attribute 1 because it's the first dimension they measured. I'm just going to call it X bar chart attribute 1. Now, click off. as charts go, this is complete. This is perfectly acceptable. One thing I might still note is the thing about ratios. The rule of thumb when it comes to graphs, and it really doesn't matter what the graph is, could be this line graph, it could be a bar chart. The rule of thumb is that we want sort of a 4:3 ratio, or a way to think about it is if I printed this on an 8.5 by 11 sheet of paper, just a standard piece of printer paper, would it fill the paper? That piece of paper is about the ratio we are going at when it comes to height and width. This one is a little, just looking at it, a little long compared to height. So I would grab this corner. One way to do it is to grab this corner and just make it bigger. And it's sort of an eyeball. There's not really a dimension you can set to sort of hit that ratio. Just sort of eyeball, and it comes with experience. Or one way that we can do it is if I right click on the chart, I can click Move Chart. And right now, this is telling me that this is an object in my first sheet, sheet 1. I can change that and make it a new sheet, and I'm going to rename it from chart 1. I'm going to call it X bar. And when I hit enter, if I go back to sheet 1, the chart's gone because I moved it, and it created a new sheet in this Excel workbook called chart 1. So it's a quick way to get the ratio right. This will take up an 8.5 by 11 sheet of paper. That's sort of how Excel is configured, that when you create a chart on its own page, it is already, proportioned correctly. So that's a quick and dirty way to get the right proportions. So this chart would be considered complete. This is perfectly usable as is. We can take this, we can copy, we can paste it into reports and things. So I, though, am really picky. So sort of consider everything after this point in the video. Again, I'm sticking with formatting. I'm not making any major changes, just formatting. But consider sort of this part, the picky part of the video, the sort of I want things to look the way I want things to look part. The first thing I don't like is if I were to copy and paste this, there's a gray border around here. And that gray border will show up when we paste it into other documents. And I don't like that. I would rather have the graph just sort of be, blending in with the white. So to get rid of that, I can click the chart area, just select the whole chart. If I come again to the fill in line, right? There's a section called border. Right now it's set to automatic. I'm just going to hit no line. And when I deselect, the border's gone. So now when I paste this into a document, it'll just be sort of what you see on this screen with white all around it, no border. That's one thing that I like. The next thing that I like is, well, I should say the next thing that I don't like is I cannot express how much I dislike the default fonts in Excel. Like, I think particularly these fonts for the titles and the labels and everything look terrible. What I prefer is that I do most of my technical writing in LaTeX, which uses a font called Computer Modern. So I prefer to take these, since the odds are strong, for me anyway, that I'm going to be using this Excel chart in a LaTeX document, that I like to make the font match. So I'm just going to select my chart home, and I've already, Computer Modern's a free font, so you can download it and install it in Windows, which I've done. And it installs, it's called CMU, but CMU Serif is the LaTeX default font. I'm going to collect that, and by selecting the whole chart and changing it, it changed everything. All these labels, the axis titles, my title of my chart. So now the font is where I like it to be. And then there's one final detail, and I promise this is the last one. If you've made it this far, I appreciate it. Again, we're strictly in the weeds of being picky and making this thing look exactly the way we want it. This axis, we have, as far as axis limits goes, we have never touched. We set the min and the max for the x-axis, and we set the divisions, but we haven't touched this one. So this is still automatic. And there's kind of a problem with that. And the problem with that is, as we add data, Excel is going to automatically update those limits and maybe the spacing. So it's going to sort of automatically rescale our graph, maybe in ways that we don't want. The other problem is this represents 1 day's worth of data. If I take, say, the next day's worth of data, and plot it this same way, and the numbers are different, Excel it might create a different axis scale. So that if I take these two graphs and set them side by side, I'm actually not able to do just a visual comparison anymore because the y-axes are different. The way to get around that is to force them to be the same, and really the way to do that is the same way we did with the x-axis. It's simpler here because these are just numbers. We don't have to mess with days since 1900. So we can just enter numbers where we want these limits and these divisions to be. But it's a good idea to do that because as soon as we manually enter limits, Excel will stop automatically updating them. That way we can be sure that today's graph, tomorrow's graph, yesterday's graph all have the same axis scale. So it's a good practice to get in. So again, I'm going to go to my axis options, open up axis options. I've got the min and the max here. And it's a bit of a guess, frankly, what looks good. I mean, it really is just what looks good. I actually kind of like where they're at. I just want to make sure they are set. So I might set them at 118.015. And I might set the bottom. Notice the bottom. See, it says auto here. So it again automatically updated. I might set that bottom to 935 is a little big. Maybe 93. 93. And what if we change this so we didn't have 3 decimals anymore? Let's change that to, well, that's okay. That actually looks pretty good, even though we're sort of missing a tick mark up here. That actually looks pretty good. I might be happy with that. The key, though, is that now that I've set them, right, it does not say auto. When it says auto, Excel could update them and basically blow your whole proportion up. The only other thing, it still says auto next to major. I might change that too. That division, though, looks pretty good. And really the key is just as long as I've set a min and a max, that means that tomorrow's min and max will be in the same place, and the day after. That means my Y scale will be the same. The major units really doesn't make that big a difference because I can still do a visual comparison between days using, as long as I've got these limits set. So I'm going to go ahead and leave it there. I'm actually happy with that. Deselected. Everything looks good to me. And again, this is our X bar chart. So again, if you sat through that video, especially the last picky part about appearances and fonts and my ramblings, I appreciate it. I look forward to seeing you in the next video. The next video, we'll talk about how to do the R chart, which realistically is much more of the same. So again, thank you for watching, and I look forward to seeing you in a future video.